Okay, so this is number 5 from your textbook review. Okay, what I'm going to do here, okay, we've learned in this particular unit that the completing the square process it takes a bit of time. Okay, what I'm going to do here is just use the partial factoring process to solve this. Okay, so it's asking us the height h of t in meters of the trajectory of a football is given by the function, where t is the time of flight in seconds. Okay, determine the maximum height of the football and the time when that height is reached. So it's asking us to find the vertex, right? And then interpret that vertex in words. Okay? So I think the partial factoring process is probably the best way to do this. What I'm going to do, just for the sake of simplicity, is rewrite the equation just in descending order. I think they're maybe trying to trick you here. It's just a quadratic, okay? Plus 28t plus 2, okay? So what we're going to do, okay, I know the y-intercept. If I substitute a t value equals 0, so if I evaluate this function at 0, I know I'm going to get 2 out, right? That's the y-intercept. Okay, so what I'm going to do is look for, I'm interested in finding what's the other time value, the other t value, h of t, that is associated with the football being at 2 meters in the air. I'm looking for that t value. That's partial factoring. Okay, so what we're going to do is we're going to substitute that fact in for h of t, okay, and solve for the other t value that corresponds with the football being at 2 meters. Okay, so 2 is going to equal negative 4.9 t squared plus 28t, and then plus 2. Okay, and what I'm going to do is I'm going to take 2 away, take 2 away. I'm going to be left with my 0 is going to equal negative 4.9 t squared plus 28t. Okay. Now I'm not going to do this to you on the test, because what this test is going to, you recall, is no calculator, right? So what I'm going to do here is I'd have to divide this out, or common factor out that negative 4.9. 28 divided by 4.9 is going to be whatever it is, 5.714. Okay, so I'm going to make sure whatever equation I give you on the test is going to be easily worked with without a calculator, right? So I'm going to remove the negative 4.9 t, and then I'm going to write in t minus the 5.7, like 14 or whatever. Okay, and from here I can actually just say, okay, well, I know already one of the values that sets this equal to 0 is 0 for t, and then the other one is t minus 5.714 has also equal to 0, and so t is going to equal 5.714. Okay, and so from this point I have my two values. Okay, what I'm going to do, okay, those would be like the 2 points in time where if the football was thrown, I'll just give you a pictorial representation. If the football was thrown from a height of, let's say, 2 meters off the ground, and this is the ground, it's telling us that at t equals 0 and at t equals 5.714, the football is at a height of 2 meters off the ground. Okay, so what I'm interested in is where is the maximum? Well, we know the maximum occurs right here in the middle, which we call the axis of symmetry, AOS, right? So what I'm going to do is find the axis of symmetry for this question. That's going to tell me after how many seconds the ball reaches its maximum height, and I can find that, if you recall, just like the last question where I was looking for the axis of symmetry. Okay, we're going to take our two x values, or two t values, I suppose, in this question, add them together and divide by 2, right? So we get 0 plus 5.74 divided by 2. Okay, and half of 5.74 is going to be 2.87. which is going to equal t. So this is like, therefore, after 2.87 seconds, the ball is going to reach its maximum height. What is its maximum height? That's what we're going to find out now, right? So we could say after 2.87 seconds, the ball reaches its max height. Okay, and again, in the interest of having a test question like this, you're going to have to be able to do this with a calculator, and I'm going to have to give you an equation that you can do the math with. Okay, so what we're going to do next now is after I found that t value, I need to find its corresponding height value. Okay, and to do that, I'm just going to evaluate the function h of t at 2.87. Okay, and that's going to be negative 4.9 times 2.87 squared plus 28. You can see this is maybe not the best question to do without a calculator, right? But if you had a scientific calculator, you'd be able to throw this all in one step and call it a day, right? It'd be pretty easy. So 2.87 squared is going to be 8.2, call it 8.24. Okay, plus 28 times 2.87 should be 80.36, and then plus 2. Okay, so we just got one more line here, and then we'll add everything up, and then we should get an answer. Okay, so negative 4.9 times 8.24 should give us a product of negative 40.38 plus 80.36 plus 2. So if I do the addition on that, we should see 40.38, negative 40.38 plus 80.36 plus 2 should give us 42 meters, if you will. Okay, 41.98, so 42 meters. So therefore, the maximum height of the ball was 42 meters high. Okay, 42 meters. Okay, so that's how you would do that question. Okay, we'd using the partial factoring process, identify two values that have the same, two values of t that have the same y values, and then find the middle of said t values. That'd be the axis of symmetry. Substitute the axis of symmetry into the equation to get your max height of 42 meters. Okay, so that's that question.